other side of the keypair in order to decrypt it. One of those keys is private, meaning you only allow it to be distributed to the one side that you're trying to have an identity at. So that would be your website in this case. The other one is public, where it's shared with everybody, because if you've got one side of it private and you're trying to decrypt something, you need to have the other key distributed. So, the X509 certificates are one of the mechanisms, the most used mechanism for encrypting websites. You put your private key in your website, you configure it up such that, like, when you're sending your information down during the HTTP challenge and handshakes and things like that, you can effectively send down your SSL connection little encrypted messages back and forth until you can determine whether or not the website you're talking to matches up to the public key for the website that you're talking to. Okay? One of the problems with this technology is that after you set up all these keys and all these configurations and all these files and stuff, and you get it working, usually most system administrators, they're like, done, thank God. And then they go off, they do whatever it is that's the next thing on their highest priority list, and one day someone will say something like, gee, how long has that key been on that website? Now, with some of the technologies, who has ever used Let's Encrypt? Okay, fantastic. Let's Encrypt uses CryptBot, right? CryptBot does this for you. So you don't have to run home and change your Let's Encrypt system. But if you were doing it manually, or if you're in a company where you generated your keys manually off of a company master key at the top, then you might have to worry about this. That private certificate inside that website is probably going to stay there for a long time. Most of them are generated with a 10-year expiration date. 10 years is long enough that somebody probably could eventually log into a web server or accidentally copy a key into Git and forget about it, or do something else, and that key could get leaked. And if that key gets leaked, then that means that an enterprising enough person could pose as that website effectively, and it would be secure. It might require a little bit of work, but the secret is out. So, Spire is a piece of software that basically takes all of your key signing infrastructure, every detail of how you generate these keys, configures it inside of Spire, and every 15 minutes re-signs a new key, puts it out on that website. Now, if you're going to break in and steal the key, you better be fast.
Wow, every 15 minutes. Wow.
You can tune it faster, but 15 minutes was about the maximum load we decided we wanted to do on Indeed with about 1.6 million keys.
Cool.
So,
Okay, so what would be keywords that we Google to?
Spiffy is the standard, Spire is the software. So if you type in Spiffy, S-P-I-F-F-E, and Spire, then there you go. You'll probably have a hard time missing it, considering neither one of those are natural English words. Yes?
Why do the keys in the system have a 10-year expiration date?
Because that's generally the procedure that system administrators follow from what they have Googled off the internet.
Why?
Because a long time ago, when people were trying to set these procedures up, the concept of rotating keys was not actually a popular concept.
I can answer it a different way too, because you can't have a key without an expiration date that gets accepted by a browser. So you can just create it long and then try to ignore the issue and screw around the fact that you can't have one with an undefined expiration date.
Right, and they were using rationalizations back then, like, in 10 years we will have redeployed this website anyway. Yes? Any more questions? You're such an engaged listener, I think you've got a question. What's up?
Oh, not yet.
Okay. All right, so how does it do this? How many minutes do I have left?
6.
On a 5-minute lightning talk? That is impressive.
Somehow gain time.
Started at 7:48 and
You
it's
know, if
now
you talk fast enough, it's got like one of those blue shift effects, yeah. Okay, so, so let's talk a little bit about how Spiffy actually does this. There are servers inside Spiffy, and these servers are responsible for generating the keys. And then there are agents, and the agents connect to the servers, and effectively the agents provide keys to any piece of software that asks for them. One of the real problems that you have is, who's heard of the bottom turtle problem? This is interesting enough to be its own 5 minutes.
How do you spell that?
Bottom turtle, as in bottom and then turtle.
Turtle, the animal?
The turtle's all behind that.
Yes. Thank you. You know. Okay, so there's a wonderful old story. I've heard it attributed to a couple of different things, but one of the things that seems to be mostly attributed is with some of the stories that are related to Hinduism, and it seems to come from India, but we're not sure. And the idea is someone asks, what supports the earth? And it's on the back of a giant cosmic turtle. Well, what supports the turtle? Well, there's another turtle underneath the turtle. Okay? And it's like, well, what supports that? And of course, the person gets tired of going through this, and he says, it's just turtles all the way down. Okay? The truth is that when you've got a secret, all right, especially a secret that can't be leaked, there's a dual problem with a secret that can't be leaked. And what is that dual problem? Does anybody know?
We what? You communicate it and then.
No, it's a secret. You should not be communicating it. The opposite of communication.
Sorry, could you repeat the question?
If you have a secret, and it's very, very, very important, all right, what's the problem that you have?
You can't communicate it, but it's important.
You can't communicate it. That's fine. That's part of it.
Are you going to lose it yourself?
You're going to lose it yourself. You'll put it on a hard drive. That hard drive will crash. Okay. You'll do something. Who has ever written a password down? Okay. Why? It's secret. You're not supposed to write it down. It even says don't write it down. It's simple. One day you wake up and you haven't used that system for 3 months. You try to log in and you're like, what was that password? Oh, I remember it had something to do with it, and you can't remember it. And it drives you nuts until you remember it, or until you call your system administrator and have it reset. The point is that if you wanted to make sure your password is in a secure place, what could you do to your password?
Keep it the same everywhere, under 2.
That's my.
Keep it the same everywhere.
Well, that's
under
one
2.
technique to reduce the number of passwords you have to remember. But the point is how do you actually keep the password from being lost? Yes?
I only use one since I have to use a password.
Okay.
You don't know the password yourself?
That's zero trust. Very clever, but not yet.
Password.
Okay? We're dealing with stupid, ancient ways that people solve this. Okay? You write the little password down on a notebook, you put the notebook in the vault. Spin the combination lock. Now you got a new problem. What's the new problem?
Now you gotta remember the combination of the lock.
Well, what do?
Write it down.
Where do you store it? It's got to be stored someplace safe.
In another lockbox.
With another key.
Spread out your lock.
This is the bottom turtle problem. Okay? If you're trying to store your password in a secure location, that secure location requires a password, that means that you've got a new password that you now have to store. Yes?
How about like storing them hashed and then trial and error until you remember?
So hashes are usually designed to not be easily reversible.
But you could
So your
match and
search
check.
space to find something that hashes to the same hash can be as large as all the atoms in the universe. I mean, you really want to make sure that you don't have to do it that way. The main reason that they store hashes is because you can't guess the password to it. So if you stored the hash and wrote it down, it's still just a problem. So the bottom turtle problem is, how do you get a secret without having the secret to get the secret. And what Spire does is Spire uses something called direct inspection, or it's informally called direct inspection. There's probably a better name for it. The point is that Spire has a registry inside of it, where inside this registry you can put the characteristics of the process. What executable launched it, checksums on the executable name, the executable contents, anything you want. You can, there's like, every different way that you can plug into Spire has its own set of selectors. If it's Kubernetes, you can do it by like pod UUID and process name and SVID, verification key. Point is that when the process asks for its X509 certificate, it communicates across a Unix daemon socket. And this Unix daemon socket has a couple of extensions that are turned on in order to see who it is that's asking. And then it'll pull the information of this process out of the process table and any other way that it needs to go and fetch this information. And it compares the information that it fetched independently with the information that's inside the request. And if the two match, then it decides that this is the correct owner of this X509 key. Because for it to not be the correct owner of this X509 key, it needs to literally, not just impersonate, but be the other process.
All right, you're way over on lightning side.
So that's the bottom churl problem. Spire uses it in order to serve out the X509 certificates. And then basically whatever process it is that needs a certificate, it just pulls every now and then so it can make sure that it always has the latest one.
Let's get a big round of applause if you think golf is horrible. There we go. Thank you. It's a stupid game for horrible people.